Research design. Research design refers to a comprehensive plan for data collection in a research study. It must specify at least three processes: the data collection process, the when, where, how, the instrument development process, the tools that are going to be used, and the sampling process, who will be studied and how do you decide that they will be included. The goal of a research design is credibility or trustworthiness. This, this goal is enhanced when the design takes into account the sources of error that may undermine the quality of the research. Examples of research designs include the experimental and quasi-experimental designs, field surveys which can be cross-sectional or longitudinal, analysis of secondary data, case studies, focus groups, action research, and ethnography. Note this list is not exhaustive. The quality of a research design is defined in terms of four design attributes: internal validity, external validity, construct validity, statistical conclusion validity. When we talk about internal validity, we're also talking about causality. This examines whether the observed change in a dependent variable is indeed caused by a corresponding change in a hypothesized independent variable, and not by variables extraneous to the research context. In order to establish causality, we require three conditions: covariation of cause and effect, that is, if the cause happens, then the effect also always happens, and if the cause does not happen, then the effect also always does not happen. Temporal precedence, very simply, that a cause must precede the effect in time, and that there are no existing plausible alternative explanations or spurious correlations. Certain research designs, such as laboratory experiments, have strong internal validity because they're able to manipulate the independent variable via treatment and observe the effect of that treatment after a certain point in time while controlling for the effects of extraneous variables. Different research designs vary in their respective level of internal validity. External validity of research design is also known as generalizability. This refers to whether the observed associations can be generalized from the sample to the population, what is known as population validity, or to other people, organizations, contexts, or time, what is called ecological validity. Designs with strong internal validity include large survey datasets. Field experiments, longitudinal field surveys, multiple case studies all have high degrees of both internal and external validities. The variation in internal and external validity for a wide range of research designs is shown in the figure on the right. Construct validity examines how well a given measurement scale is measuring the theoretical construct that it is expected to measure. Many constructs used in social science are difficult to define, much less measure. Statistical conclusion validity refers to the extent to which conclusions derived using a statistical procedure are valid. For example, it examines whether the right statistical method was used for hypothesis testing, whether the variables used meet the assumptions of that test, and so forth. Improving internal and external validity. The best research designs are those that can assure high levels of internal and external validity. Controls are required to assure internal validity of research designs and can be accomplished in 5 ways: manipulation, elimination, inclusion, statistical control, and randomization. In manipulation, the researcher manipulates the independent variables in one or more levels and compares the effects of these treatments against a control group where subjects do not receive the treatment. This type of control is achieved in experimental or quasi-experimental designs, but not in non-experimental designs such as surveys. In the elimination technique, we eliminate extraneous variables by holding them constant across treatments. For example, by restricting a study to a single gender or a single socioeconomic status. In an inclusion technique, the extraneous variables are considered by including them in the design and estimating their effects on the dependent variables separately. Such techniques allow for greater generalizability, but also requires larger samples. In statistical control, the extraneous variables are measured and used as covariates during the statistical testing process. Finally, randomization technique is aimed at cancelling out the effects of extraneous variables through a process of random sampling and random assignment. In random assignment, subjects are selected in a non-random manner, are randomly assigned to treatment groups. Randomization also assures external validity, allowing inferences drawn from the sample to be generalized to the population from which the sample is drawn. Generalizability across populations is harder since populations may differ on multiple dimensions, and it's difficult to control for all of these. The internal validity of a research design. History. In the context of internal validity, history refers to extraneous incidents or events affecting the results that occurred during the research. This is a threat to any research that is conducted across points in time, and it becomes more serious as the time between measures increases. If some event occurs during the study that is plausibly related to the dependent variable, it is difficult to know if the independent variable, the event, or a combination of the two produced the result. In this case, the event is confounded with the independent variable. The two cannot be separated. History can occur within the study as subjects are affected by something that happens during the treatment in an experiment, or outside of the research setting. History also includes confounding variables that are associated with levels of the independent variable. For example, suppose an experiment compares two methods of instruction. One treatment is in the morning and the other is in the afternoon. Time of day would constitute a history threat associated with the level of the independent variable. Selection. There are two types of selection threats to consider: those that occur in experiments and ex post facto designs, and threats related to sampling. In experiments, groups of subjects are formed in order to study an independent variable of interest. If there is a systematic difference between the groups, however, it is possible that the results may be due to those existing differences. The threat of selection exists whenever groups of subjects cannot be assigned randomly, and although there are several approaches that can help control this problem, in cases where randomization is undesirable or impossible, adjusting post-test scores on the basis of initially measured group characteristics and giving each group treatment, the researcher should always be concerned with this important threat. A common problem in research is using volunteers for the sample. The volunteer group may be more motivated or motivated for special reasons. Hence, they would respond differently to the treatment or questions from the way a non-volunteer group would respond. Statistical regression. Statistical regression refers to the tendency of subjects who score very high or low on a pretest to score closer to the mean, regress to the mean, on the post-test, regardless of the effects of the treatment. All measures have some degree of error, and statistical regression occurs because of changes in error from the pretest to the post-test. Scores on the post-test will be different from the pretest for students on the basis of mathematical probability alone because of this error. For groups of students who score either very high or very low on a pretest, this error works to change the scores on the post-test so that they are closer to the mean of the post-test than they were to the mean of the pretest. Regression is a problem whenever the researcher purposely chooses groups on the basis of extremely high or low scores. A school district, for example, may want to implement a special program to improve the self-concept of children who score low on a self-concept inventory. An assessment of the impact of the program could examine self-concept scores after the program, but the researcher would have to keep in mind that even if there is no program effect whatsoever, the initially low scores would improve to some degree because of statistical regression. Similarly, it is usually difficult to find positive changes in programs for gifted children, since because of regression, post-test scores will tend to be slightly lower on average. Pre-testing. Whenever research utilizes a pre-test, it is possible that the test itself will have an impact on the subjects. Just taking a pretext could provide the subject with motivation or practice on the type of questions asked, or familiarize the subject with the material testing. This kind of pre-testing effect is found in experiments measuring achievement over a short time and in research on attitudes or values when a single group is given a pre-test and a post-test. Instrumentation. A threat to internal validity as relating to testing is called instrumentation. Instrumentation refers to the way changes in the instruments or persons used to collect data might affect the results. This threat is particularly serious in observational research, when the observers may become fatigued or bored or change in some other way so as to affect the recording of data. Subject attrition or mortality. Subject attrition occurs in a study when subjects systematically drop out or are lost during the investigation. This is a threat to many longitudinal studies that last over several weeks, months, or years. Mortality is essentially the same problem as selection, but it happens after the study is already set up and underway. Maturation. Maturation refers to changes in the subjects of a study over time that affect the dependent variable. Subjects develop and change as part of growing older, and in interpreting research that occurs over an extended time, such changes should be considered. Some changes, such as getting hungry, tired, bored, or discouraged, can occur in a relatively short time and are also considered maturational threats to internal validity. For example, students who become more knowledgeable because of experience, or first graders who learn to dribble a basketball not because of an effective teacher, but because they are maturing physically. Diffusion of treatment. In experimental designs, a treatment is given to one group, and the control or alternative condition group never comes in contact with the experimental treatment. Each group knows the conditions of the other group. Treatments are diffused throughout all the subjects. It is possible that both treatments could affect either group, resulting in diffusion of treatment. Experimental effects. Experimental effects refer to both deliberate and unintentional influences that the researcher has on subjects. This may be reflected in differential treatment of subjects, such as using a different voice tone, being more reassuring to one group than to others, reinforcing different behaviors, displaying different attitudes, selectively observing different subject responses, and any other demeanor that influences either the subject's behavior or the evaluation of the behavior by the researcher. Experimental effects also occur if the characteristics of the investigator or person collecting the data, such as clothing, age, sex, educational level, and race, affect subjects' responses. In most research that involves the use of researchers as part of the study, it is best to keep them unaware of the specifics of the research. They need to have only enough information to carry out the research objectively and to collect the information. Subject effects. In ideal research, the subjects behave and respond naturally and honestly. However, when people become involved in a study, they often change their behavior simply because they understand they are subjects, and sometimes these changes affect the results. Subject effects refer to subject changes in behavior, initiated by the subjects themselves in response to the research situation. Statistical conclusion. In most educational research, statistics are used as a basis for making conclusions about presumed effects and relationships. There are several principles of statistics that, if violated, can affect the inferences made from results, as well as subsequent conclusions of the research. Researchers need to understand that the use of impressive sounding and impressive looking statistics does not guarantee valid results. The best approach is to consult with a statistician who is familiar with these threats.